I'm going to go through some of the standard lines used by vested interests that want to sow the seeds of doubt in people's mind, or maybe even people who legitimately doubt or have questions. So we have to nonetheless be very aware of all the scientific facts and the ways to describe them, right? So the most common one used by the, let's say, contrary view on climate change debates, we'll come back to that in a minute. They always say climate has always changed, so this is nothing new. Okay, well, yes, climate has always changed. This is data from an ice core on Antarctica, the Vostok ice core, which shows almost 1 million years of ups and downs in temperature, carbon dioxide and methane, and we understand this physics very well without going into details of how we get this signal out of the ice core. Either you're an expert and you know it, or you are trying to learn this, and I can tell you that there are ways in which glaciers form by snow falling in one year, not melting, getting compressed, and trapping bubbles and growing into glaciers and keeping the signal over long times. So Antarctica has several kilometers thick glacier. So does Greenland, for example, and several mountains like the Himalayas. And you can drill into them and extract the signal from the past. In the past, we know very well that the changes in the Earth's orbit, like the ellipticity of the orbit, the obliquity or the tilt, and what is called precession, so the Earth wobbles and the orbit itself kind of precesses because of the gravitational pull from Venus, Jupiter, Saturn, and so on. So we know this physics very well. We can even predict perfectly when the next changes in orbital forcing come from, thanks to Milankovitch, Milutin-Milankovitch, and these ice age cycles typically are called Milankovitch cycles and so on. So there is no doubt that climate has always changed. We can go all the way back to the beginning of the Earth's formation 4.6 billion years ago. Continents moved and caused climate change, but CO2 has always been a part of the story. Okay, but we also know that what's happening now is that we are increasing carbon dioxide very rapidly, and we have gone beyond anything we have seen in the last 1 million years or longer. So this is from 2014. As of 2020, we're already into 418 or so ppm, parts per million by volume. Methane has increased a lot, but you can see methane is in parts per billion by volume. So these are called trace gases because they are in small amounts compared to nitrogen, oxygen, and so on. Okay. And there is the temperature anomaly with respect to the base period. So we cannot always get absolute temperatures in the past, but we can get change with respect to the current climate. There are ways to do that. We know that very well. Okay. The other, so in that sense, we know that climate always changes, but right now we also know the greenhouse physics so well that we know exactly how much additional energy gets trapped because of these increases in CO2 and methane, nitrous oxide, HFCs, CFCs, and so on. We can say clearly how the increase in greenhouse gases is related to the warming. The other key thing they always argue is that look at the change in temperature. So here, these histograms, these bars are showing temperature change again with respect to the baseline before the into the 19th century through 20th into the 21st century. And you can see that the blue bars here correspond to times when temperatures were colder than the present baseline, and the warm colors are when it's getting warmer. Okay, but the main thing they argue is that look at the CO2. It's constantly increasing since Industrial Revolution. Here we are at 418 or so, and the temperature doesn't increase correspond to the CO2. Well, we know very well that the energy in the Earth system goes into different boxes, as we will see in a minute. And that's what causes these ups and downs. So the seasons are still changing. Day-to-day energy input from the sun changes because there is sunset and sunrise. That heats the ocean, that heats the atmosphere, land, glaciers are melting, and so on. So energy is distributed in different places. And because of the seasonal changes, sun is still going north-south, sun is still rising and setting. This causes internal feedback. So evaporation of water cools the ocean, condensation of that water in the atmosphere warms the atmosphere, clouds are formed, water is moved, it rains somewhere else where the energy is released, and so on and so forth. So we know very well the physics of why temperatures go up and down. But we also know that this warming is now pretty monotonic, especially since the 1980s, where each decade is now warmer than the previous decade. So year-to-year variability on Earth's climate will not disappear. Seasons will still change. We'll still have winter, summer, fall, and spring, but certain things systematically change. The warming happens so spring arrives earlier. Winter is not as warm anymore, but you can still get extreme snowstorms. Summer is hotter, daytime temperatures are increasing, nighttime minimum temperatures are increasing, and so on and so forth. So there are many evidences you have to put together. The energy in the system, ocean takes up almost 93.5%. Atmosphere has very low heat capacity, no memory, so it only keeps 2.3%. Continents are taking up about 2.1% because they also have very low heat capacity. Glaciers and ice caps are melting, so they are using up the energy produced by increased greenhouse gases, energy trapped by greenhouse gases. Arctic ice is melting and taking up the energy. Greenland, Antarctica. So we know very well why temperatures don't rise uniformly even though CO2 rises uniformly. Okay? Then they will say, but how do we know this CO2 is coming from us? Maybe it's coming because glaciers, last ice age ended, glaciers melted, and CO2 is coming out. Well, we have ways of explaining that as well, as we will see in a minute. So I'll split these into multiple podcasts so that you can systematically go through these arguments and see what the science behind is and why these arguments are not scientifically rigorous. And nonetheless, you can get on TV, say them quickly, and leave, and people will not bother to check the details, and they will believe it because they already want to believe it. Okay? But the idea of climate change science communication is that you make the effort to always clarify these doubts. So we will see a couple of websites that do that. As we said, skepticalscience.com, realclimate.org do these clarifications all the time. Many of the figures you see I have actually selected from those websites.